This topic is to solve integrals by substitution. The substitution method is also called as U substitution because over here in this method you take a complicated term and substitute as U. That's why the name U substitution. Now before we start this, look at this problem equation. This is a very hard problem to solve by simple integral whatever we have learned till now. So now, to make this less complicated, we do this substitution. Basically, we are manipulating this equation, integrating, and then getting back to the original. Like whatever we have assumed, we are putting it back. Let us see how we are doing. Now, assuming the value for u is not a constant. See, it depends on each question. So you need to solve more and more problems on this to get a better understanding. But whenever you have e to the power something, it's better. See, this is a complicated term. Put it as u. And it must be so taken that the other factors also will be eliminated. Let's see this now. See, eu. Now, sorry, I'll take it u equals square root x. Now, I've considered this term as u. But remember, if I have integral of, say I'll take a simple term, x square, I'll have dx over here. Same way, if I have integral of m square, I'll have dm. Now, if I have integral of u square, I should have du, isn't it? If I'm substituting u over here, I should integrate with respect to u, so this will be du. So what do we do? So that is why we need to differentiate this and get du. But it won't be just du, it'll be du by dx. Sorry. Because we are differentiating with respect to x equals, this formula for root x is 1 by 2 root x. This is it. Now what do we do? You need dx, so keep dx at one side, okay? And other things to the other side. 2 root x over here, du will be equal to dx. Now substitute this and this back to the given equation. Then you can see it will be simplified. Integral of root x is u divided by root x dx is basically, sorry, instead of dx we write 2 root x du. Now you can see there are terms that cancels. This cancels with this. And now 2 is a constant, take it out. Integral of eu du. Isn't it so simple to solve the integral of eu? Now we'll do it. The integration of exponential anything will be same thing. It is u itself, but plus c. This is not over. Don't forget we had taken u as root x as u, sorry. For simplification, it will be simpler to solve. Now put it back. E root x plus c. So this is the real actual final answer. So you can see the final answer would be, so 2e root x plus c. This e is correct, eu, but remember we had substituted root x as u, so substitute back. That is the final answer. Similarly, you can solve the others. It is just that you need to take the appropriate value to substitute. Then it is basic integration. So let us just look into the values over here. See, whenever you have cos, it's easier you take this. And when you take this, even the other values get eliminated. The questions will be so given that you should take one u value and then the term gets reduced. So now over here, you have 1 by x as u. So what happens is when you differentiate this, it will be minus 1 by x square. And then rearrange to get dx. This goes out the side and it becomes minus. And then you can simplify it. See, root x cancels. And this minus sign prevails. Integration of cos u will be sine, positive sine u, but this minus sign will be there. But don't forget to substitute back what was u. 1 by x was substituted as u, so put 1 by x back. That's how we solve it. Please do solve the other problems as well. Now over here, it's inside root, right? Because when we had e to the power square root x, we took this entire term as u because it's much simpler. But now don't take this as u, just take the inside term. Why? Because when you derive this, you're going to get this part, isn't it? X to the power 3, which will cancel off. See, you just have to substitute u as x to the power 4 plus 3. Derive it, you will get du is equal to so much. But you need to have only dx. So what happens is dx equals du divided by 4x cube. So whenever you change this dx to du, it will be divided by 4x cube. Hence, this cancels and you will have a simplified form. Now, you can see the steps over here. U is x to the power 4 plus 3. This is very important. Derive this, get dx. Substitute everything back over here. It will be square root u, but a square root is taken as half, and this cancels, and 1 by 4 is written out, constant. Integrate this by adding plus 1 and divide by plus 1, and you can easily get the answer. So don't see, this is the answer, yes, but don't forget to substitute whatever you took as u. So this is the final answer. Same way over here, this is similar. Whatever is inside, substitute as u. See, over here, when you integrate, it'll be just number. So that's fine. And you'll just get a constant. Over here now, see, again, see, it's better to take whatever is inside. You can't take sine because it'll be more complicated, because it's easier to solve root u. Why? Because you can you know how to solve that. Whereas if it was sine x, if you are taken u divided by root u, very much complication. Though you can solve it, it's better to take u, whatever is inside the square root. So in this case, we take cos as u value and then derive, substitute and do the same thing. Same way over here. Now over here, it's not the same thing. It's see, you need to understand thoroughly, because there is sine cube. If you take sine cube over here as you derive it, you will get a complicated term. You can't do it. Now, if you take cos also, you won't be able to solve properly. So what do? You're taking sine from here. See, take sine as u. Derive this. What will happen? When you derive, you will get cos dx. So now just take this cos to the other side. I will just do this once again. U is equal to sine x. Du by dx is equal to cos x. Okay, differentiation of sine is positive cos. Now what is dx? Dx is equal to du by cos x. Now let me substitute everything back. See, sine I have taken as u. So how many sine is there? 3. Sine to the power u to the power 3 into cos x. And now I have du by cos x. So this cos x cancels. You have only u to the power 3 du to integrate now. Isn't it easy now? U to the power 3 du. Integrated, you will get the answer. Substitute back the sign. That's it. So please go through all the u values. See, and u values whenever it's inside sine or cos. See, this is generally taken as u. Even over here, this will be generally taken as u. Only this, not the power, only whatever is inside. So once you know the u values, it's pretty straightforward. Now, we have done similar problem, e to the power. So whatever is there in the power, we take it as u, for only for the e thing. Now, in this case, say don't take x as u. If you take x, you can't solve it. Because there is square root, you need to take whatever is inside square root. This entire term is taken u, and then you can simplify and solve it. So I can't tell you exact method, though there are some baselines. It depends on the problem and it differs as well. So try to solve more problems and you will easily understand. So over here we had done this initially. Square root x was u, and over here whatever was inside cos. Please do the other problems by yourselves and then check for the answers.